So today we're going to talk about lenses and how lenses work. This will help us understand a lot of different aspects of everyday life, including our glasses and our eyes and telescopes and cameras. And so this is the beginning of understanding all of that. So first we're going to talk about something called the Thin Lens Approximation. And that will help us a lot with some of the lens stuff that we're going to do moving forward. So here I have drawn some kind of lens. In this case, there's two curved edges, and I have drawn our object and arrow, as well as just this straight line here is just the optical plane of the lens right in the middle of the lens. So generally, when you are thinking about a lens, right, we'll have to think about refraction. So in reality, what is going on is you have a light ray that comes in, it will hit this first edge, and then because of Snell's law and because lenses typically will have some different index of refraction than whatever they're sitting in, so you have some index of refraction outside the lens on either side, and then the lens itself will have some other kind of index of refraction. So this light ray will come in, it will hit this lens, and then because we know it will refract due to Snell's law, it will bend at some angle inwards. And then it will hit this other edge, and right, we have a change in our index of refraction, so it's going to bend again, okay? So this is generally what the ray diagram would look like whenever you want to see how a lens is affecting light. And this is for some lens where it has some thickness, T. Now the thin lens approximation, the thin lens approximation allows us to say that the thickness of the lens is much, much smaller than the radius of curvature. That's what this R is here, the radius of curvature of the lens. And this will really, really simplify our ray diagrams for us. So what this does is it changes this diagram. I'm going to draw the diagram again, right? So this is our lens. This is the optical plane. We have our object. Now what we're going to do is we're going to say that because we're going to use this approximation here, there's some optical plane that the lens is sitting in that's just sitting right in the middle of the lens there. And so now when we draw ray diagrams, we're just going to say they go straight to that optical plane and they will bend after that point, right? So this approximation allows us to sort of skip this intermediary step. Now we can draw a couple things here. I'm going to actually extend this ray a little bit further, and I'm going to draw a second ray so we can try to find where our image is located. Sometimes this happens. You'll have to keep extending your rays until you can find where they intersect. There we go. There's our image, just like we did for plane mirrors. So remember, this is our object, this is our image. Now this object has some height h. Our image has some height, we'll call it h prime. The object has a distance, and so does the image have a distance, s prime. So this is our general setup when we're talking about lenses and ray diagrams. This is typically something that you will see, and then remember the thin lens approximation allows us to sort of skip this intermediary step and go straight to the refraction at the optical plane. I'll leave this as an exercise to you. This is just a matter of geometry, but the thin lens approximation allows us to write down this equation: 1 over s plus 1 over s prime is equal to 1 over the focal length of the lens. This is extremely useful when you have some information about your lens and you have where the object is located, right? You can figure out exactly how far away the image is going to be located on the opposite side of the lens. Similarly, we can write down something about the height difference here. So what we can say is that the magnification m is equal to the height of the image, h prime, divided by the height of the object. So this tells us how different is the height of the image compared to the height of the object. So this is lenses, at the very beginning of lenses, and we will be using the thin lens approximation as we are moving forward because it makes our life a lot easier, and it is a pretty good approximation for lenses that we'll be thinking about.